everyone, thanks for stopping in. Take a look at the new project. This one's going to be on what I have termed a micro power station. I have a Bouge RV 30-quart fridge, portable fridge, horizontal, whatever, and it needs a battery. Needs a source of power for camping trips and travel and so forth. So I have a lithium iron phosphate battery. It's a 12 volt, 20 amp hour battery that wasn't getting used for anything. So I've opted to put together a little power station for it. And but I've got a container that will hold multiple batteries if need be, or I can swap it out for like a 50 amp hour, something like that at some point. This is my third attempt at making this video so far this morning, and now my neighbors decided he needed to screw a bunch of tin on the side of his house, so we'll just put up with that because I'm tired of waiting. Just real quick, I'm going to run through my plan for putting this thing together, and we're going to start up here with the battery. And again, it's a 12 volt, 20 amp hour, and lithium iron phosphate. It's going to come out, this is the positive side here in red. Comes out through a 30 amp circuit breaker and goes through a master cutoff switch, and it's going to go down here to a power distribution block, and this is a 4-circuit block. I can change this out for a bus bar at some point if I need to, and then add inline fuses or whatever, but for now I have a distribution block, and it's going to feed a like a service panel that has its own switch, and that switch will turn on power to a power pole input or output. There's a USB port, and I'm going to cover all these parts in a little bit, plus there should be a list in the description below that covers the entire parts list of what I use here, and then also a 12 volt socket. So each of these will be coming off through one fuse here, so I'll be real protective of that. This is a negative bus bar down here. Looks like you're in frame. So anyway, we've got the battery going out, feeding that, goes down this, what I'm calling a service panel. And then it also is going to come over, and one circuit will come out to an XT60. There will be a switch that will put it in circuit. And that will be my primary. External to this, I will have either a solar input via an MPPT controller, or I can also plug in like a little 5 amp LiPo4 charger or something like that. The thing with this battery is that the battery comes with a limitation on it of maximum of 10 amps of charge current. So I will make sure this is fused at that, so we don't try to feed more back to it than I don't want to damage the battery. But anyway, so this is interchangeable. This could either be a solar panel with an MPPT controller. Well, that could be PWM, I suppose. But anyway, it'll either take a solar input or some kind of external charger. We'll be able to power that or feedback through this power block and charge the battery, as long as that switch is on and that switch is on. We'll also have another power pole outlet. This one's going to be rated a little bit higher. Probably do this one at 10 amps, maybe something like that. Just for whatever. I mean, I could feed another charger of some sort, either solar or grid power or something back this way, or just use it as a 12 volt source for some kind of load. And then I've got 2 different sets. I ordered some LED strips. There's 12 LEDs per strip, and these take about 1.5 watts each for each strip. So, and I'm going to set it up so that with one strip, I can either turn on just one strip, or I can also flip on the other switch and turn on an extra 3 strips just to increase the light level if that need be. One thing I don't have on here, I did buy some little, they're made to illuminate a license plate, because here in the US, in pretty much everywhere I know of, you're required to have a light on your license plate so it can be read by, the people out there helping us on the roads. So anyway, I don't have that shown on here, but that will also be coming off probably one of these fuses here, I would guess. I may just bring it straight off of this cutoff, because I need to be able to illuminate my work area to make sure I get the right switches on and stuff like that. So they may just come on when they do this master cutoff switch. I'll decide on that as we go. And then the last item in here is the volt amp meter, and it's got its own. It has a shunt available, so it's gives you a little bit more precise measurement of the power being used out of the battery. Unfortunately, I mean this is going together on a budget, so I did not get the more expensive version that shows all the power going in and out. I'd have to wire it a little bit different with the solar input if I did that, but this one will show you what's coming out of it as far as amps, what's being used, and then also the voltage will be some decent indication of the status of the battery. And knowing that if I get down below about 12.5, I'm going to shut things down and make sure I get charged up again. So anyway, that's where we're at with the circuit wise, and I'll just move on and show you briefly the materials I'm going to be using, and then a brief look at the tools I plan to use. And if I add any to that along the way, I'll show those to you as well. Well, here we go. Let's try this again. Apparently it's going to be a third time's the charm all the way through this video. Man, I tell you, it's just been a heck of a day. Anyway, we'll just run down the list here real quick. This is an ammo can I'm using. It's made by MTM. It's a model AC11 ammo can. Its outside dimensions are 8 3/4 long, 15.5 inches wide, and 9 inches high. Inside, it's got 7.5 inches long, 13 inches wide, and 7.25 inches high. So more than enough for the battery. I'll show you next. It does have an O-ring seal, but by the time I'm done with it, it's not going to be waterproof anyway, so I'm not too concerned with that. And it's made of polypropylene, handles up to 30 pounds of gear. The battery I'm using, this is one I purchased about 3 years ago, and it's had very little use. I did use it some with amateur radio on one of my portable rigs. I don't have that portable rig anymore, and the battery's just been kind of sitting. I do test it and charge it occasionally, make sure it's in good shape, and it tests out good. So anyway, it is Expert Power is the brand name on it. It is a LiFePO 4 lithium iron phosphate battery. It's rated at 12 volts, 20 amp hours, and it has 256 watt hours, 12.8 volts nominal. It has a maximum charge rate of 10 amps. It's identified right on the battery itself. It measures 3 inches deep by 7.25 inches wide by 6 3/4 inches high. When I first bought this, it was only about $130 or so. I bought it on the Jungle site, and I checked it a few days ago, and it's still about same price. Actually, it's a little bit cheaper now, so you might be able to pick it up on sale or something one of these days. These are a little bit harder to see out here in this light, but anyway, these are the license plate illuminators that I mentioned. Is not on the schematic or the diagram that I showed you earlier. It comes in a pack of 2. They're 12 volt LEDs, and each one draws 240 milliwatts. So the two combined is still less than 1 watt of draw on it. And I'm not sure 100% yet where I'm going to tie it in. I think it'll come off the same fuse it's going to what I'll show you as the service panel. But anyway, those are intended to illuminate the switch area, the control panel area, so that I can see what switches I'm turning on and off and so forth. So that's the whole purpose behind those. Next up is this is the negative bus bar. I bought it as a set. I've opted for now to not use the positive bus bar since I'm using a power distribution block. I do reserve the right to install the positive bus bar later if I'm going to enhance this system or reconfigure it in any way for like multiple batteries and so forth. But essentially the negative bus bar is it's rated for 150 amps DC. It has 10 contact points. The actual bar itself and the hardware is stainless steel. It has 2 M6 studs, one on each end, and then there's 8 M4 screws, machine screws, that for connection points. It does come with the hardware for mounting, as well as ring terminals, both M6 and M4 ring terminals, to make connections, where you can use your own. I will probably use some of my own. And that's it for the bus bar. We've got a total of 5 rocker switches. These are just simple on-off, single pull, single throw type switches. There's going to be one of them used for the main cutoff switch that will go between the circuit breaker and the load distribution panel. So it'll come from the positive lead will come from the positive for the battery, go through the circuit breaker first, and then to the switch, and then from the switch to the load center of the load distribution panel. So one of those will be used for that. There will be one switch used to turn on. I've got 4 LED strips. And we'll talk about that in more depth. But I want to have one switch power one strip, and then if I need additional light, I'll have another switch power the other three strips. So it'll be a maximum illumination that I have available. Still only around 600 lumens, but it'll still illuminate an area. And there will be one switch is going to be used to isolate an XT60, so the solar connector or the external charger input will have to go through a switch, as well as the additional power pole connection. There will be a total of 2 power pole connectors, 30 amp style, and one switch will turn that on and off and be able to isolate from the system. So I'll have use for all 5 of those. There is an additional switch on what I'm calling the service panel, and I'll show you that here actually next. This is what I'm calling the service panel. It's one of your standard. You buy it, put it in your you put it in your RV or your side-by-side or your whatever. They're very popular. Put them in. I see them being installed in boats, and I have in some cases installed them on golf carts and so forth. This particular one has a toggle switch on the left, and that will be fed via a fuse from the power distribution block. That switch will engage the next 3 items on there. The one next to the switch, just to the right of it, is a power pole. It's a 30 amp style. It's going to be probably fused to 10 amps. And next to that, then, working to the right, is a USB. There's a total of 2 USB-A connections in there for a total of 4.2 amps. It's 2.1 amps per. So I can charge like phone, tablet, whatever. And then the last one on there, and kind of the purpose behind this build, is the 12 volt socket on the right hand side there. It's a cigarette style socket for 12 volts, and that's what my mini fridge will plug into and power that. So let's see, the switch does have an LED in it to indicate that it's on, which should be fairly obvious anyway. Let's see, I mentioned the power pole connector. The panel came with an LED voltmeter installed where I have the power pole next to the switch. And I took that out since I'm going to have a different volt amp meter elsewhere in this build, and I didn't really need the redundant voltmeter in there. And then, like I said, the 2 each USB 2.1 amps and a 12 volt cigarette lighter style lighter. I intended to point out earlier, but I'll mention it now. We're looking at the little yellow item right here. That's an XT60 connector that will be mounted. It's a panel mount connector. The battery power, like I said, it's a 20 amp hour, so you're not going to drain just a whole bunch of amperage out of this thing, hopefully. And so coming off the positive and negative terminals will be 10 gauge wire, and the positive again will go through a circuit breaker and onto a switch and into the load center power distribution block. And up to that point, I want to use 10 gauge wire. and also the negative lead off the battery going to the negative bus bar will be 10 gauge. Everything else in here will be 12 gauge wire, because we're looking at a maximum of hopefully 20 amps on anything in here, so everything will be fused appropriately. So anyway, that's why I opted to use an XT60 rather than like an XT90. Since I'm not going to use 10 gauge on it, it's only going to get 12 gauge. It'll handle it just fine, and that's what we got set in here. It's connector simply via solar or external charger connection. It's got a recognized maximum of 20 amps. That's the battery limitation, so a 12 gauge wire will work just fine. Okay, now we're looking at the circuit breaker. This is a 30 amp circuit breaker, so it's really not going to do us much good unless there's some kind of catastrophic, just a direct short circuit or something like that. This will pop, and I have tested it. It does work. I don't know the exact point, but I saw 29 amps, and then the next thing I heard was a pop, and when I looked, of course the amp meter went to 0. So anyway, it does work. It's been tested. Everything's great. It's the primary battery protection. Again, it'll connect between the positive terminal of the battery, and the output will go to the main cutoff switch, the toggle switch that we talked about earlier. The volt amp meter, and we're right here. It's not a high dollar unit, but it had good reviews where I purchased it from. It does have it'll operate 0 to 100 volts. It handles up to 50 amps. The shunt is a 50 amp shunt, so it's way sufficient for this build. It's got a red and blue dual LED display. The volts display in red and the amperage is in blue. And let's see, the shunt, the span on the shunt for you techies out there is 75 millivolts. All right, I've got a total of 4 LED strips. I got a couple of extras if I need them, backups or whatever, but I want to use 4. I'm going to have one strip powered off one switch, and then if I need additional lighting, I can hit another switch and turn on an additional three strips for maximum. These are 1 foot long each, and I'm just going to put them up they'll be stuck on one side of this device so I can have some area illumination. They're bright white in color, 12 volts. They operate on 12 volts. I've tested each of them. They all work fine. Each one is approximately 150 lumens, and so if I turn on all 4 at the same time, it'll be around 600 lumens total. That's not a lot, but it beats trying to work in the dark. They are waterproof, and they've got a self-adhesive strip on the back of them. There's 12 LEDs per strip, and like I said, 1 foot each. Last item I got for you on the materials list, what I plan on using, is this is the power distribution block. It'll hold up to 4 the spade type automotive fuses, and the little metal stud you can see on the back side, right there, that's the 12 volt input, and then the terminals, there's 2 on each side, goes out, and each of those are fused. It includes an LED for each one, so if there's power applied and a fuse is blown, the little LED will kick on and say, hey, you got a problem here. I've used a few of these on golf cart upgrades. Normally I'll use one that has like 12 outputs, but for this micro power build, 4 is going to be plenty. And that's it. It's got a 4-way blade fuse box, and it uses LED indicators for blown fuses. And it's got the little clear cover you can see down there in front of the blue box. And that's it for materials. Just real briefly, I'll show you the tools I plan to use, and then we'll get going. For tools, it shouldn't take a whole lot. You can see I've got up here some step bits, drill bits, a couple of different wire strippers. I got a measuring tool here, plus I'll have a tape measure out here, obviously. Little pair of long nose pliers if I need to reach down and either install or remove like a spade lug terminal type thing. Wire cutters, and then just a simple set of drill bits. I got to do, other than the step drills, I'll have to drill a few holes like for the leads going in from the LED strips going into the box. I'll drill a small hole for those wires, and I'll probably seal that with hot glue when I'm done, either silicone or hot glue. We'll see how it goes. I don't have any silicone here, so I'll have to get some. I do have plenty of hot glue. So anyway, that's the tools. I mean, obviously I'll have a drill out here, a little hand drill, and that's going to be about it. So I'll get going on this, and I'll bring you along for bits and pieces of it at least. It's really kind of a pain in the butt to work around this camera, and I really need to get this done in a fairly timely manner. So I'll tell you what we're going to do. I'm going to show you the general placement of what I got in mind. We'll see what I actually end up with, but you got to have a place to start. So yeah, I'm going to show you that, and then I'll probably throw in a little clip here and there as I progress along getting this stuff done. First of all, the lid in here can't really keep you in frame, but the best shot for a place to put this volt amp meter is over here in this corner. There's a nice open spot right here that'll work well for that. So that's going to end up there, flat down in the top. This panel here is going to go this way, and I'm going to end up changing this switch out. It turns out this switch is rated a little bit higher than these others as far as current wise. So I want to pull that out and take this lighted part, because this has got an LED in there to show you when the power's on. That should be fairly obvious, but anyway, I'll make use of that. And I'll put one of those other switches back in here, and that's going to power up the power pole, the USB, and the 12 volt socket. So that's all the switch that goes here is going to do, is just power these three items. And that's going to go right down here. Now I think I want to move that, put that down about halfway down or so. And I'm going to put one of these license plate lights. I want to put it up here in pretty close to the top, shining down across these connectors, this switch and these connectors. And I'm going to try to configure it so that when I turn on the main cutoff switch, that at least one of these lights is going to come on and show this panel. I mean, it pulls, like I said, less than half a watt, so I'm not too concerned with battery consumption on this. The other one, since I'm going to have controls up here on the top, I'm thinking somewhere along over in here, maybe shining back this way across the controls I'll have up here. But again, I'm planning on having the volt amp meter up here, and there is room. I could put the little circuit breaker right in between the meter and the main cutoff switch. So I'll have one of these switches, like I said, the one with the LED. I'll put it over here on this corner, and so that'll be kind of the lineup to get this thing powered up and ready to provide power. And then I'm thinking that I will go ahead and spread the rest of these switches out over here. That's what I believe will happen. And then, like I said, maybe the one license plate light maybe over here shining back this way to highlight these. As far as the other gizmos, I have the single power pole connection that I want to put next to the XT60, and I'm thinking that'll just go back here on the back. I'll have them side by side, and that way it'll be in a separate area. I'll know that's kind of potentially, I mean, either one could be used for an outlet. They're going to be wired to the bus or to the power once the main cutoff switch is turned on. These will be have energy available to them, so you can backfeed a charger to either one of these. You can put a solar charge controller connected to there via solar panels, whatever. So thinking those will go back here. The shunt, of course, for the volt amp meter is going to go down here. So it's going to go down in the bottom, down in here straight. It'll be pretty much directly under the where the meter is. And I took a thick, well, it's actually a plastic cutting board. Thank you, Dollar Tree. Anyway, it's like a 1/2 inch thick plastic, and I just cut out a spot to hold the battery secure in here. And here's the negative terminal, so that's just going to come right down to the shunt right here. So that's going to work out well. And also I have room over here for the power distribution block. I have room over on this side, and here's your positive terminal. So that's kind of the way that's going to go, pretty much right in the middle here. It'll be down out of the way, and you can see that by the time I mount these in here, it's going to be close to the back of the battery, but it shouldn't quite be touching in there. So, and then the last item are the LED strips, and my plan for those, we're going to go over here and run back to the hinge side, and right back here on this corner. The wires will feed in here, and then I'll probably silicone or hot glue. I'm thinking hot glue would be sufficient. And anyway, these will line up here. There'll be all four strips are over here. So if I need some area lighting or whatever, I can turn one or all four of these on. And I think that's pretty much it. That's the plan. So as I make progress with each of these, I'll cut you back on here and get you up to speed on what I got done. A little bit of an update. I've got a few things mounted in here. I got the volt amp meter mounted, circuit breaker, all 5 of these switches. The way I proceeded with volt amp meter, I took and measured with one of these, and then locked it down. It's got a little lock screw on there, and then I was able to use that to scribe lines on here. And then from there it was just a matter of running a razor knife down in here, box cutter style razor knife, and cut that out very carefully. The circuit breaker fits between the 2 ribs here perfectly well, and that comes over. This will be the main cutoff switch. Yeah, I changed my mind on swapping out that switch. It wasn't going to work out. This one's rated heavy enough. Again, we're just talking about 20 amps maximum on this, and most of the time it'll be considerably less than that. So this will be fine. It'll work just fine. I haven't labeled anything. I haven't hooked any of these up yet. But this one will be the main cutoff switch. Inside, I was able to drill a couple of holes in the ribs that they used to stiffen the lid up here, and ran that one down there. And then on the other side, this will come down, and of course I got to run a negative lead up here too. But I'll do some cable management here that'll keep this. I'll just bundle these cables together when I'm all done. It should allow it to for the lid to close adequately and not pinch any wires or anything. I also don't want to cause any metal fatigue on by opening and closing. It doesn't need to be open and closed that much, but every time you do, there's some bending going on, so I'll try to minimize that. I have the shunt for the volt amp meter up here. The shunt is mounted, and I've just got the negative lead connected through it per the manufacturer's suggestion, and then it runs over to the negative bus bar. For positive, coming off the battery, comes up here to the circuit breaker. So that's the very first and main level of protection. And then it comes out of the circuit breaker over here, comes over to the cutoff switch, and then from there comes back down to the power distribution panel. I've pretty much determined that there will be one 2 amp circuit that's going to run the lights, the LED lights, strips, and then the other 3 are all going to be 20 amp fuses that I'll make use of down here. So, and I'm not sure, again, I'm still debating on the whole license plate illuminators. I do want to use them, and I'm still figuring on using them as I had described. But I do have a couple of extra of these little toggle switches. They don't have the flange that goes around there. But I'm wondering, I can envision a time and place where maybe I'll be using power out of this thing, and I don't want any lights on at all. So I don't want to have like the one up here I was talking about. The one up here being on anytime the main cutoff is on. I don't want that. So I want to be able to shut all the lights off. So I'm thinking I'm going to go ahead and add a couple more light switches, and I may just put those down here on the front. There'll be one for the top and the other one for this side over here. So that is where we're at right now. Here we go, another quick update. I ended up mounting one of the license plate lights up here, and then I got a switch right here, more or less beside it, that turns it on and off. And the other one is up here on the top. It's yeah, it's fairly early morning here in South Texas, so the sun is once again pretty intense. Anyway, I put another one of the lights up here, and I checked it out last night. I have it so that it will power up now. I checked it last night when it was dark, and it does a pretty good job of illuminating these switches here, so you can kind of see what's going on. And I've put a switch here pretty much right beside it. Before I stopped for the night, last night I got these. Stick this up here. Not sure how well this is showing up in this light, but anyway, I put these self-adhesive or adhesive back strips on here, and I clamped these in place. I laid a little piece of plywood over the top and clamped these down. Actually, I wiped this down with alcohol yesterday before I started to make sure there wasn't any oils or anything that was going to interfere with the adhesive, and then applied each one, and then laid a little piece of plywood over the top and put a couple of clamps on there and let it set overnight. So they seem to be pretty solidly in place. And then the wires, I opted to just come around and I drilled this is a 3/8 hole, and I put a 3/8 grommet in here. And I can still seal this with silicone or hot glue, whichever. I'll probably seal it with hot glue, probably on the inside, I'm guessing. But anyway, and now, I don't know. It's troubling that these are kind of hanging out here, but I don't have a lot of slack in them, so hopefully they won't get caught on anything. I could put some kind of wire or loom holder or something like that on here to assist with that. It may not work out. I may have to change it in the future, but that's what I got going for now. And I'm not sure what I had covered in the last update, but yeah, I do have, this is all installed and can be powered up. I tested it and made sure that all of these connections work and that kind of stuff. So that's where I'm at for now. Moving on. Here we go with an update. I am pretty much done with this. As far as I know, I am done with it. Right now, it's I did some testing while I was in production here, so I've got my little 5-amp LiFo4 charger plugged in, and it's charging the battery. But so anyway, yeah, we've got a little map light or reference light here. I'll try to show this again when it's dark. See if we can see it on camera. There's a light up here that also shines, pretty much illuminates all of these switches. I got a lot of labeling to do, but I'll get that taken care of. Anyway, I got a power pole on this side that I can either use as a 12-volt source, like an outlet, or I can plug in my charger, which I'm doing now, and charge it up. I also have an XT60 that would work the same way. I have most of what I have for solar panels for the power stations that I have built use the XT60 or an XT90 if it's more higher current. But anyway, most everything so far is running XT60, so I can plug that in here, but I can also use this as a 12 volt source of 12 volt power if I need it for something. And as I explained before, I've got a little on-off switch here that just powers up this panel. These are there's an extra power pole here, USB, and a 12 volt socket here. Up on top, this is what I'm using for the main cutoff, just the very first one on the hinge side. And you can see that right now the charger, in fact it just now turned green, so it is fully charged, so 14.4 or 14.5. And it's got a 30 amp circuit breaker here. This is this first one is a light on this side. The first switch turns on one LED strip. The second switch turns the other 3 on, so I can turn on all 4 and have pretty decent amount of area light just to see what's going on in the area. But I can also turn those off. And then these two are, this one is for the power pole here that connects it back to the bus. And I can turn that off. I'll turn this off here. If we do that, you can see it would start to, yeah, see it's a drop there. So, and then this is also true for the XT60. If I'm charging this way, in order to charge it, I would have to have this switch on, and the master switch would have to be on. So, other than that, I think it's going to work. I want to do some testing tonight and let it run some equipment, and then tomorrow I will plug it into some solar and see if we can get it charged back up. So I guess that's what I got. Oh, I'll just go ahead and show you inside. What the heck. I did kind of okay with cable management. This is the volt amp meter up here. Here's your circuit breaker, and this is the main on-off switch here. And then for these, I left plenty of slack so nothing gets really super tight, but then I did a couple of cable management bundles here and brought that up. On this side, here's the back side of the service panel here. I use these are Wago knockoffs, and I found them to be so very handy. They come in the sets that I buy. They come in 2s, 3s, 4s, and 5s. I'll just show you. I've got some set right here. I got them separated out because I got a bunch of them. So I got all 3s and 5s in here, or 3s and 4s rather, in here. So, and then they have a little holder thing if you're going to mount them on a panel or something that way, and then I got the little screws to go with them. And then I got these, the 2s and 5s over here. So it's just so slick. I did a little bit of soldering on this project, but not very much. And there's just really no reason to when you got connectors like that, because they are very secure. I've done several of the golf cart upgrade projects, and I use those pretty exclusively for making my connections for like the 12 volt system and that kind of stuff. And they've been rock solid as far as performance. So what I see as potential problem with this is these strips, while they seem to function quite well on things, I'm already seeing where they might be popping loose. The adhesive on the back's not that great. So worst case scenario, I have to come up with some kind of way to lace these in here, or some kind of bracing to go across to hold them in place. I could also get like some 3M double-sided tape and put that on here and then stick them back down to that. I bet that would hold. So other than that, they seem to work pretty well. And I just brought those in here and run all the grounds down here to common, and then the positive sides that came up to the appropriate switch. So anyway, I want to get this labeled up and do some testing on it. I'll bring you back tomorrow when I'm doing some solar power, assuming we have sunshine to do that with. Should be. That's all we ever get here. See you in a bit. I'm going to try to finish this up. Status is not for last. I used this little rig to run some medical equipment. It worked just fine, ran it all night, did everything I needed. And then yesterday, I spent the day with this connected to some solar panels, 100 watts of input through the battery power MPPT charge controller, charged back up just fine. So that tells me that I can use this for at least the medical devices. I have not tested it with the Bouge RV mini fridge yet. I will test that. I don't know if I want to record that or not. We'll see. I haven't gotten a lot of feedback from anybody, so I don't really know what you want to see. I'm picking and choosing. But here's where we're at on this one. Now that it's been a couple of days, you can see the adhesive. These strips are fine. They work great, but the adhesive on there is highly questionable. So what I got, I realized this was going to be a problem. So day before yesterday, I ordered some things. It's individual little clips. Now these all have 3M based adhesive on the back. They just pull a little tab off and you got the adhesive right there. But they also have a hole in here for a screw, and they included a bunch of screws. So anyway, you put it in place and then you fold this over and hold that down in place. So what I'm going to do is I'm going to go ahead and stick these on, but I'm going to run, it's just a little bitty screw. I'm going to run it in all of these. And so, yeah, there'll be a bunch of sharp little pieces inside there, but people shouldn't be reaching in there anyway. Anyway, I'm going to install this and get these strips lined up and so that they'll stay put. And that's probably going to be about it. If somebody wants to see something else done with this unit as far as testing or something, you're going to have to leave a comment. I know apparently it's painful or something because nobody's doing it, but that's how we get better. Is you tell me what you want to see and I do it if I can. Anyway, I will. I'll put some of this on time lapse, and you can just watch, and then I'll show you, give you a little demonstration at the end here when I'm done with it. The adhesive is good. Kind of already stuck together. I'll start down here. So if I do that, 3, 4, 5, 6. believe it's latched in there now. Yay! Okay, I'm going to take you off the tripod, so quick, take your anti-nausea pills. Guessing that you just saw the area lights, area light 1, so this turns on one strip, area light 3, and it turns on the other 3. Power pole, I can't tell if that's in focus or not, it's junk cameras. Anyway, power pole, and I put a C on there to remind me it's for the charging power pole, which is here, and it also has a matching label. And then the service panel here you turn on, there's obviously a power pole here, and the USB and the 12 volt. Now the 12 volt socket is the one I use to run the medical gear overnight, and it worked great. And then yesterday when I was charging this via solar, I used this XT60, which requires getting your MPPT charge controller connected here and turning this on so it's connected to the battery, and then plugging in the solar panel to the other end of it. And it worked great. It took about 4.5 hours to fully charge it. I think I averaged about between 3 and 4 amps of charge current. It was sort of like today, with there was variable clouds, a few more clouds than there are today, but it worked actually very well. And of course, overnight, then I had to try out I'm calling them map lights, which makes the most sense to me. So there's this one here, and it does a good job of illuminating these. And then I have this one down here, which also makes these perfectly visible at night. So anyway, that's where we're at. We're still fully charged, and I think that's probably going to do it. Like I said, I'm gonna plug in the mini fridge to it and just see how long it'll last. I don't know if I want to throw that on the end here or not. Probably not. We'll see how it goes. And if not, well, thanks for watching.